Compost is human initiated, very important part of this definition, human initiated, managed, and second really important piece, accelerated decomposition. So it's human initiated and it's accelerated. It's the decomposition of organic matter that benefits plant growth activities through these different ways. And in the background, this is a large scale. There's some cars in the background, so you can see how big these rows of compost are. So some farmers take this to the extreme and do large scale composting. So this would probably be an organic, large scale farm. What is organic matter? Or organic material, rather. So organic material originates from living things. All kingdoms of life produce organic material. So that's lichen in the forest, that's anything that comes from arthropods. This is all kingdoms of life. They're all carbon-based, and they may contain plenty of nitrogen. So this includes woody material, and some examples are dead leaves, wood chips, manure, mowed grass. And so if you look at the top right corner of this slide, you'll see a wood chip colonized by fungi. So if you can look closely at there's some white right there on top. So that would be called mycelium of the fungi. So the fungi is breaking that down. How does that work though? So fungal mycelium, you can see here pictured in the white stuff right there. It is using enzymes to break down lignin. Lignin is what gives woody material its hardness. Fungi are the only microorganism that can break down lignin. So this is very important in nature because before fungi evolved, lignin did not break down. It's a very interesting part of Earth's evolution. But now, of course, we have fungi, and fungi is responsible for breaking down the woody material in our forests or in wood chips that we use in the compost. Right in the middle there is 400 times. And that is what the fungal mycelium looks like. So when you see the white mass, you're looking at a lot of fungi. And in the right, you could see a mushroom. So if you have mushrooms popping up in your garden like this, don't be scared. That's just the fungal mycelium reproducing and spreading its spores into the world. You can see at the bottom right corner, there's a little black line. That is also mycelium. So this piece of wood is undergoing decomposition because of the fungi. All parts of fungi are considered organic material. Breaking down organic material, so you can see on the right, that's where we start. That's what a lot of people end up putting into their compost piles. So we have their flowers, buds, leaves, kitchen stuff, trash from the garden, it all ends up in a pile, right? So if you have a pile like this in your yard, that's not compost, it's organic material. So you have to put the organic material through a process of mixing and management. And once you do that, the soil food web takes over and you have a process called mineralization. And we'll talk about that in a little bit. So the soil food web is made up of arthropods and microorganisms and very small animals like worms. Also some larger animals too. And then once it undergoes that process of mineralization, it all of a sudden looks like this rich, dark brown or black compost. The benefits of compost are increased soil aggregation, soil pH buffering, and it offers sustainable fertilization. So we'll talk about what all that means, starting with increased soil aggregation. Okay, soil aggregation increases oxygen and water infiltration, aids nutrient adsorption, difference there between absorption and adsorption, and contributes to a healthy rhizosphere. So that term rhizosphere is a little bit of an advanced term, but it's important that we talk about it because every plant root is its own micro ecosystem. And we will talk about that on the next slide. But the plants are producing carbohydrates that leak out of the root and feed microorganisms. We call that area surrounding the root the rhizosphere. This is what aggregation looks like in soil. So this would be well aggregated soil. You can see how it's not smooth. There are pores in it. So a soil aggregate or soil aggregation really describes a situation in which macro porosity exists, humus exists, and soil food web activity exists. So in an aggregate, you will find these three things. A macro pore is defined as being larger than 0.08 millimeters. You can see where I've circled in this picture I made what a macro pore looks like relative to micropores. So if you follow the blue drops down as gravity goes down the soil profile, as they move through the soil profile, you can see that water can sometimes get caught up in the little micropores where it is unable to escape. So water can only escape from the macropores in soil. So that's either through evaporation or a plant root grabs it or something else utilizes it. But all those micropores, those really, really small pores, water doesn't escape those pores. Plants can't get to them, but they'll stay there. In addition, in a soil aggregate, you have areas of humus, humic substances, and those are the black triangles. These areas cling to nutrients, positively charged nutrients. So they increase the fertility of your soil because they grab onto nutrients and they hold them there. In addition, because of the macropores, oxygen from the atmosphere is allowed to diffuse down into the soil profile. And this is important because roots need oxygen. Microbes need oxygen. The oxygen can only get into the soil through macropores. So if you have a hard pan soil, you may have an anaerobic environment. So what is the soil food web? The soil food web is incredible biodiversity in soil. It's really kind of mind-blowing how many different kingdoms of life are in the soil. But we'll start with the macrofauna, which are the bigger animals in the soil, the bigger arthropods. So we have earthworms, and these are the different kingdoms that they represent: worm, crustacean, or sorry, the different orders of life they represent: worm, crustacean, diplopod, insect, arachnid, columbella. And as you go down the list here, you can see at the very bottom all these different forms of life. They're so different from each other: protozoa, nematodes, fungi, bacteria. These are different kingdoms of life. It's interesting to note that at the smaller we get, the more biodiverse the life gets. So when you see things in your garden, like this cockroach here, that's a good sign. That means that things are happening. The food chain is going on. But what are trophic levels? That's not a word you hear very often. Trophic levels. This is a widely dispersed handout from the USDA, from the NRCS, the Natural Resources Conservation Service. They use this image a lot. The different trophic levels are at the bottom: 1, 2, 3, and 4. So we're the 5th, we're 5, we're higher level predators. That's human beings, that's animals. But all the way at the front, at trophic level number 1, you have plants, really the basis of any food chain. As the plants photosynthesize, they produce carbohydrates. The plant exudates leak into the soil. And the second trophic level takes over. The microflora, the microfauna, the bacteria, fungi, they start feeding off of these carbohydrates the plants leak. In addition, they are also decomposing any dead organic matter that the plants have left behind. After a plant senesces and it sits there in the soil, fungi and bacteria will use enzymes like we described earlier, like lignin breakdown. And then the third trophic level are these things called shredders. So they are going to help your compost speed up into a usable product. So they are actually very beneficial to the composting process, the shredders. And the reason they're so beneficial is because they accelerate it even faster. So where you make your compost, it's important to consider which pesticides you're using around your compost. Are you providing an ecosystem around your compost so that it can be sped up and accelerated? So, and then the macrofauna, the third level, the third trophic level, consumes the mesofauna and microfauna and organic matter as well. Okay, so we're back to this slide, and now we will talk about soil pH buffering. Soil pH buffering is a term that soil scientists use to describe the phenomenon that happens through large surface area. So decomposed organic materials are termed humic substances, and we have these 3 substances coming out of humic substances: humic acid, fulvic acid, humin. You may have actually seen these products advertised, and they can be beneficial to the soil. They are the broken down forms of organic matter. On the far right upper corner, you can see this is a molecule of humic acid. CHONS is an acronym that stands for carbon, hydrogen, oxygen, nitrogen, sulfur. So that's what a humate or a humic acid molecule is composed of. They are called carbon macromolecules. They are recalcitrant. Recalcitrant is a term we use to describe something that can't be broken down any further. And they are negatively charged. This is really important. If you can look at, if you see this handful of compost passed through a 2 millimeter sieve, the plus signs represent the nutrients that it catches. Because it's negatively charged, it catches these nutrients. Most importantly, ammonium, potassium, magnesium, calcium, but ammonium is a macronutrient. Ammonium is a very important nutrient. That's nitrogen. So the large surface area resists changes in pH. And this is what you want, because when you've got a good pH in your garden, you don't need it to be shifting. And increases the number of cation adsorption sites, CEC. That means that it catches more positively charged nutrients or cations. All right, now with the last benefit of compost, sustainable fertilization. We'll talk about why compost is sustainable. Sustainable fertilizer. Compost contains plant growth promoting bacteria. You might have heard them. They're called PGP bacteria. PGP bacteria produce a chemical called siderophores, and they chelate micronutrients. Specifically, iron is chelated. It's wrapped up in this chemical, an organic substance. It wraps it up like a present and hands it to the plant root. So that allows more absorption of micronutrients. Increased aggregation leads to situations in which microbes, beneficial microbes, are allowed to flourish because of that increase in oxygen and that regulation of moisture. We see things happening on legumes, like rhizobia nodules, like this picture in the upper right corner. Rhizobia takes nitrogen from the air, literally from the air, and it turns it into a plant nutrient, ammonia, with an A at the end. That's NH3. NH3 is not positive, it is neutral. So in addition, when we have good aggregation, enough oxygen, good moisture regulation, mycorrhiza can begin to combine with plant roots. We call this VAM fungi, vesicular arbuscular mycorrhiza. Mycorrhiza has been proven many times to increase access to phosphorus in water. But there's still a lot we do not know about mycorrhiza. And we know that it connects plants. Could it be some form of plant communication? It's a good question. But why is ammonium NH4 plus, why is that sustainable? So when we talk about sustainable fertilizer, ammonium should come to your mind. Positive. Well, first of all, it clings to the compost. It clings to it. So is it going to get washed away when a gully washer comes through? No, but nitrate will. Nitrate is negatively charged. It readily gets leached or washed away in water. And now we have problems with hypoxia, algae blooms, specifically the Gulf of Mexico hypoxia zone. 20 miles out from the Gulf of Mexico, fish don't survive because of the lack of oxygen. Look it up. It's a big deal. So, and this is coming from the Mississippi Valley, where everyone is using anhydrous ammonia. and nitrates to fertilize. But what is nutrient cycling? So let's roll up our sleeves and look at how nitrogen moves through the environment. So we know that our atmosphere is 70% nitrogen. Dinitrogen gas and nitrous oxide gas. We know that legumes harvest nitrogen and produce ammonia. Then ammonia gets turned into ammonium and clings to the soil. Mineralization converts organic material to ammonium. And that happens through, you look at this chart, organic N goes to ammonium, NH4 plus, using the soil microbial community. So that is either through the soil microbial community using ammonium as a energy resource, or plants taking it up, or producing it, and then it sits there in the soil ready for plants. Okay, now we come to the fun stuff. This is my workspace. This is where I make my compost. Few things to note. First of all, I'm under a tree. I don't make compost in the sun. Some reasons for that is that the sun exposes my ingredients to drying. Microbes don't like to be dried out. They like a lot of oxygen, but the sun kills them, dries them out. You need access to a hose. You're going to need a tarp. You're going to need some wire fencing, a pallet, a rake. I highly recommend 2 different kinds of pitchforks, a 10-tine and a 5-tine, a hand fork, and a wheelbarrow. All right, when we start mixing browns and greens to make our pile, there's a simple recipe and an advanced recipe. The simple recipe is half browns, half greens. You can't go wrong with that. You will get a product. It may not be the best product, but you'll get a product. Browns consist of wood chips, dead grass, dead leaves. They have low nitrogen and high carbon. And greens represent products with higher nitrogen, fresh stuff, fresh shoots, fresh leaves, freshly mowed grass, kitchen waste. With the advanced recipe, we introduce a third of the composition, inoculum. We'll talk about that in a second. So overall, the process is to mix ingredients, load into the cage, add some water. This is the advanced version. So you can see we start with the browns. You lay out your tarp and you pour your ingredients in lines on the tarp. Then you use the tarp to overlap the lines. This tremendously helps with mixing. You just have to lift the tarp up and it mixes your ingredients. You do that on each corner. And then you take your pitchfork, bring it all back to the center, make it into another line, mix it again. Yard waste is dead grass, leaves, old brush, the stuff that you cleaned up from your yard. It's very, very important, extremely important to soak your wood chips overnight. Can't stress this enough. This is an integral step of making compost. You have to soak your wood chips overnight. With the greens, we have manure from herbivores only. The reason we want herbivores only is because we don't want to introduce any parasites from omnivores or carnivores. So no, unless you are a very advanced composter, do not use your cat, dog poop. Only use herbivores. So this means horses, chickens, sheep, cattle, hogs, if you're feeding them just vegetables, and then grass, leaf cuttings. I recommend making compost on the same day that you cut your grass. You want to lay out your browns, mix them up, lay them back out, then cover it with grass, and then add your inoculum. Inoculum is finished compost. So you need to get the best product possible. You need to have already finished a pile. And you use a bucket from that to inoculate or add a source of beneficial bacteria, fungi, protozoa, and nematodes. You're adding this, and then it can proliferate. You're going to multiply everything in that inoculum. It's going to speed up the process much more. I can provide that if you come to the office. I can give you some finished compost, just a small bucket. That's all you need. You could take that home for free. And then your moisture, you want to be between 40 and 70%. So unless you have a moisture gauge, you won't know the exact percentage. So you're going to have to do it by feel and by sight. By sight, it should have a nice sheen to it. It should be a little bit reflective. If you hold a handful of it, it should be a little bit reflective of the light because of the moisture in it. And if you squeeze it really, really hard, you should be able to get a couple drops out. When you're preparing your compost, it's very, very important. If you have manure, you must pulverize. Must pulverize. Having a 10-tine fork is probably the easiest way to do this. If you don't pulverize your manure, you will end up with pockets in your compost that are anaerobic and start to cultivate the wrong microorganisms. So we want to make sure that all of our manure pieces, this picture is horse manure. You want to make sure that it is very well broken up. And again, herbivores only. The wood chips, please, no pieces bigger than 2 to 3 inches. In addition, anything you clean up from your yard, unless you are a very advanced composter, don't put plant pathogens or any kind of weed seeds in your compost. And you need to soak your wood chips overnight. Very important to soak the wood chips overnight. Your layer of fresh plant material, preferably it's freshly mowed grass. Now, the final step in the preparation is to prepare your fencing into a cage. So you'll need wire cutters, 7 feet of fencing length, and that's either 4 or 5 foot tall. If you pay to come to my class in person, I'll provide you these materials for free. In addition, I won't be giving out the pallet, but you need to build it onto a pallet. The reason the pallet is important is because it allows airflow through the bottom as well. And it allows any water, excess water, to drain out. So if it happens to rain a lot, that water needs to be able to get out of the pile. So you're going to lift the corners of the tarp to mix easily. And then once it's homogenized and mixed very well, you'll use your pitchfork to load the compost into the cage. What you're achieving by doing that is this picture on the right. So you'll have a bottom layer, a top layer, and in the very middle, you'll have what's called the hot middle. The hot middle is where your compost is cooking. And when I say cooking, I mean that is where the accelerated decomposition is occurring. You don't want the hot middle to get too hot, though. So when you build up your pile, you need to take it apart and redo it in 3 days. Don't wait longer than that. Because if it gets too hot, then the wrong microbes can start to form. So we want to keep the hot middle between 120 degrees Fahrenheit and 140 degrees Fahrenheit. There's compost thermometers online, available online. I recommend getting the 24-inch style. That way it can reach all the way into the hot middle. And on that one, it has indicators as to where the good zones are and the bad zones. Anything above 150 degrees is getting too hot. If you get the compost middle, if that reaches 190 degrees, it will light on fire. It will combust. So if you've ever heard of like a barn fire, starting on its own or anything like that, this could have been the reason. So this is what it looks like when you've got it laid out. On the left, you can see my wood chips that have been soaked overnight. And then the fresh grass on the dead grass on the furthest left that's cut out by the picture. And then my pulverized horse manure on the right, a line of it. Then once I have them all lined up and laid out like that, I cover it with the fresh mowed grass. And then I come with my bucket of inoculum, spread it all over. And then I use the corners of the tarp to easily mix all this stuff up, along with my pitchfork to fluff it up. So, like I said, we'll lift the corners of the tarp to mix it. And then you can see the empty cage behind the tarp on the pallet. That's what you'll need to make. You load it all into the tarp, into the cage, and you let it start cooking. In 3 days, you will turn this pile, and it's very important to turn it correctly because you want every piece of organic material that you load into there to undergo a hot middle cooking session. Every piece of organic material that you load into this cage needs to make its way into the hot middle and be there for 3 days. So you'll load it into the cage initially, wait 3 days, and then you will break it down. And this is where part two of making compost will pick up. So part 2, I will teach you how to turn this pile so that each part of every single organic material that you put in there makes it to the hot middle. So you will undergo 3 or 4 turns, and then after the 4th turn, or maybe 3rd, you'll have a finished product, a dark brown product. These are the terms that you should know after today's class. So root exudates, carbohydrates produced through photosynthesis and released outward into the rhizosphere. The soil food web is the aerobic topsoil ecosystem containing microorganisms, macro and microfauna, and plant roots that function together to cycle organic material and provide habitat and respiration for its constituents. An aggregate, a situation in which the soil contains sufficient macro porosity and allows an aerobic soil food web to function. And organic material, pieces or residues originating from living things, animals, plants, microorganisms, etc., carbon-based and may contain plenty of nitrogen. And lastly, humus or soil organic matter, which I have two scholarly definitions, because this definition of soil organic matter, it gets tossed around a little bit. So these two resources will sort of give the debate a little bit of a conclusion. So I like these definitions. It is the humus that includes the recalcitrant organic matter that resists further decay. So this definition is basically, you're talking about the carbon macromolecule. It doesn't break down any further than that. And then a second definition, the carbon component of organic matter that is measured in the soil that passes through a 2 millimeter sieve. So that would be this stuff. That's humus. So I look forward to anyone that's signed up for the part 2. So I can teach you how to start turning the pile. And it's a little bit more complicated than it may seem, because we need to establish an oxygen channel into the compost to make sure that our pile doesn't go anaerobic, because if it goes anaerobic, then we're not doing our job. Our job is to multiply the beneficial microbes. And our job is to cook every part of that. So for this week, and if you haven't done so already, gather these ingredients. If you're not making your compost in the shade, move your compost to make it in the shade. Don't make your compost in the sun. You're just making your life harder. Make sure that you get yourself a tarp. If you're making compost without a tarp, then you're going to have a harder time mixing it. You'll break your back trying to mix these ingredients by hand. And get yourself a pitchfork. If you don't already have a pitchfork, get one. And a pallet. Pallet is very valuable to allowing enough oxygen and the water to drain out of the bottom. So please type any questions you may have in the chat box, and please click on the survey. There's a small quiz. And I will start looking at these questions. Okay. Can I get access to this video in case I mix something? Oh, yes. Yes, this video will be on YouTube. I'll post this. How do you prevent critters from going after your vegetable peelings? Oh, that is such a great question. So there are many options to prevent critters, and it depends on the critter. So if you want to type in which critter, if you're talking about like possums or armadillos or raccoons or cats, then that becomes a pest control thing. I used to do pest control, so to catch a raccoon, if you've got a problem raccoons can get pretty smart. So you want to try to catch them the first time. And I used to catch them with go down to Tractor Supply or Ace, and get yourself a medium-sized cage. I think it's the weight is for 20 to 40 pounds, and you're going to prop that open and use cat food. Get yourself some wet cat food or tuna if you don't want to spend too much money. Get yourself a can of tuna, prop open the door, set up the trap, put the tuna in the very back of the cage, and catch that raccoon. They can be kind of mean when you first come up to the cage if you catch them, but you need to dump the raccoon. Don't kill it, but move the raccoon at least 5 miles. Travel at least 5 miles from your house, and then let it go at a creek. If the problem's a raccoon or a cat, if the problem's a cat, I mean, if it's feral cats, now we have feral cats here, but they don't mess with any of my scraps. But if it's rats and mice, then you need to look at a mice hotel or a rat hotel, and I would, you can use poison, desiccating poison. Bromadiolone is the active ingredient in that stuff, and but make sure whatever hotel you get, your dog can't get into that. So there's a few great websites online that I like. DoMyOwn.com, they're really great. There's some other pest control websites. You got Lowe's and Home Depot, they sell stuff. But if you go with a pest control company, you're going to pay a lot. So I would recommend doing that yourself. If your problem is deer, then there are some products that you can buy synthetic urine. You can urinate yourself, to try to pass the message out that this is your territory. They sell blood. You can buy different kinds of blood to deter deer. They sell different types of olfactory stuff that they don't like, or taste stuff they don't like for deer. And if all else fails, you may have to just build a tall fence, or encapsulate your scraps. And I think I covered all the critters. Okay, why do you need to soak wood chips overnight? Oh, that's a great question. So the wood chips can't begin their process of breaking down unless they have a habitat that's suitable for a microbe. Microbes don't function when they're dry. So when you soak the wood chip, soaking it overnight, specifically soaking it overnight, is so that the water can really make its way into the center of the wood chip. So that way the fungus has an easier time diving through all the cellular spaces and using its enzymes to break things down. The fungus also utilizes water. I mean, the fungus needs water to live. So if things dry up, then the microbes will go dormant. And if you were to just put dry wood chips into your compost pile, what you would find is that the pile would not start breaking down. It would kind of just stay dry. Things would just stay dry. It's because the microorganisms, or the soil food web, that's the engine. So in the engine, like in a car, runs off gasoline, the engine of microbes runs off water and the organic material. Those are the two things that the microbes need, is moisture and organic material and oxygen. So that's why it can't be too wet. But if you soak just the wood chips and combine everything else dry, then the moisture will kind of diffuse out of the wood chip into everything else. Now, also, after you build your pile up, you want to run your hose over it a little bit just to get the outsides wet, because you do have evaporation coming out from the outsides. Okay, there are lots of pallets in my development. If oh great, that's really nice of you. What can you do for hydrophobic sandy soil? So for sandy soil, when you add the finished product of compost, so for sandy soil, the problem is that the sand is too large to be able to catch anything. The smaller just as a general physics point, the smaller something gets, the larger its surface area gets. So when you take a sand grain and you compare it to a humate, the amount of surface area on a humate is so much greater than the amount of surface area on a sand grain. So that's why nothing clings to sand, or very little clings to sand. So when you add your compost to the garden, then the humates will now act as an area that moisture and nutrients can cling to, and thus you'll start to build your organic matter. Things will stop washing away or leaching out. As far as composting kitchen scraps, would you recommend adding in citrus like lemon and lime? Could you add in cooked grains and pasta? Okay, everything in moderation with this. So there's really nothing that you can't add as long as it's not a lot of it and you're doing the process correctly. If you have just all lime peels, then I would not recommend that. The key word is variety. So the more different kinds of the different browns and greens you can add in, the better. If you have all of just one thing, then you could get some weird results. And as a side note, there are some wood chips that you want to stay away from. So that would be black walnut and hickory, and also camphor trees. So stay away from camphor trees, black walnut, and hickory. Now there is some evidence that shows that you can compost those things. You can, but this is for very advanced composters. So when you're just starting out, stick to pine. You can see I have pine bedding all under, and pine is what I use. Pine breaks down easily, but hardwoods are good too. Aspen trees. I mean, really any hardwood besides black walnut and hickory and camphor will be fine. The more different kinds of wood chips you can add in, the better. So these, I mean, there's different types of lignin structures and sugars and things like that. The more diversity you can introduce, the better. And about cooked grains and pasta, yeah, those are fine. But if you added sodium to your water when you were cooking it, I would not put that in there, because sodium is toxic to plants. So if you, and that goes for anything that you want to compost, like your leftover scraps, that's fine. But if you used salt to cook them, I would just throw that in the trash. I'm in an area heavy in pine trees and still have some in my yard. Can and how much pine needles and grass clippings be included? And then do I need to add some lime? Oh, that's an interesting point. I'm glad you brought that up. So if you look at some of the historical videos from the USDA from the 40s and the 50s, there are some how to make your own. They used to call compost, they just call it manure. I mean, really the technical definition of manure is compost. It's not necessarily from animal feces. But they used to actually recommend adding lime to your compost, layering lime in. So you don't need to add lime if you have enough aeration. And part of the reason why we're making the compost in this cage is to allow enough oxygen in and around the pile so that you don't start to cultivate the wrong microorganisms. You don't want to cultivate the sour organism. You know, if you get a sour smell from your compost, that means you are not getting enough oxygen into your pile. So some of the old videos from the USDA, they used to say add lime into, and they didn't recommend making it this way. They would recommend making it lasagna style, adding layers to make your compost. When you do it in layers, you end up with pockets of anaerobic environments. The lime in that situation was to sort of stifle the growth of any sour microbes. But if you're doing it this way with the cage, you have more than enough oxygen. With this cage method, with the pallet, your problem will be more, how do I retain moisture? Which is why we're building it in the shade, because we don't want the sun blasting it. But managing your pile to retain moisture is a lot easier when it's in this cage setup. Okay, and so that's the last question. Yeah, this presentation will be on YouTube though. And please take a second to respond to the quiz that I posted at the top of the chat. And everyone, thank you for attending today. Really appreciate it. And sign up for part 2 so I can show you how to turn the pile and continue the accelerated decomposition. Okay, there was another part to that question. Ken, and how much pine needles in grass clippings? So the pine needles are going to be considered a brown, and if you want to just keep it simple, you can go half browns, half greens, or 1/3 browns, 1/3 greens, and 1/3 inoculum. Hope that answers the question. Okay, I'll leave this open just for another minute, just so you guys can still use the chat to click on the quiz. The quiz, just a two question quiz. The first question is, do you feel confident in sourcing your browns and greens? And the second question is, name 3 benefits of composting. We'll just leave this open for another 30 seconds. If you're still here in the webinar, remember, if you sign up for the in-person class on the 28th, I will include some inoculant to take home with you, and then I will also include some fencing too, so you don't have to go buy a giant roll of fencing. You can just with the registration fee of $35, you can get your you can get some fencing, and I'll show you how to build it, so you could just have one fence at home, not have a whole roll. The quiz is, I posted it at the top of the chat. I can repost it again. There it is right there. Okay. I think that should do it. Thanks again, everyone, for listening in, and I hope to see you at part 2. Bye, everyone.